Hello viewers. So today we are going to solve a problem on the lead code. So we are going to solve a problem for linked list cycle. So let's just read the problem and try to solve it. Firstly, we need to analyze what is the problem. So let's just get started. So given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. Okay. So basically what this problem is saying that in a linked list there can be a cycle, and if cycle exists we need to return the node where the cycle has started. If there is no cycle we need to return the output as null. Okay, so let's just read further. There is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. It is -1 if there is no cycle. Note that position is not passed as parameter. I think this here is talking about the inputs. Let's just see how the input has been passed. And they have mentioned do not modify the linked list. So basically they are asking us to tell in place only, like where we need to point to the node in a list only, existing list only, where the this cycle has begun. So let's just see the input, how they're passing the input. So there's a head 3, they're passing a list of nodes, and then they're passing a position equal to 1. Okay, so that's what, yeah, now it is self-explanatory whatever is written here. So they are telling that position is used to denote the index of the next pointer where it is connected. So that means suppose in this example, if you see the input 3 2 0 and then 4, so 4 is connected to 2, and the 2 is at index 1. It is a 0 based index linked list, so index is 1. So if you see the index 1, then the -4 node is going to point to the second node, so whose position is 1. So this is how the input has been given, but they have mentioned that note that the position is not passed as a parameter. That means we don't need to pass this one. Our input will be this one only, and we need to determine based on this one only. So otherwise if they are passing this one, then there is no problem. This is not a problem. Otherwise the solution exists here only. So they're just passing us this input and we need to find the solution for this one. So okay, so what they're doing is there's a cycle in a linked list and we need to find out where the starting point of the cycle is. So I think, yeah, so you can think of any solutions. Take 10-15 seconds, otherwise I'll go ahead and then, yeah, I'll start with the solution. So whatever comes in my mind, I'll tell you the first approach. So the problem consists of 2 points here. So firstly we need to find out if there is a cycle exists in this linked list or not. So if at all there is a cycle, then we need to find out what is the first node of that particular cycle. If there is no cycle exists, then we need to return it as null. So there are two approaches here to solve this problem. The first approach that I'm going to talk about is the simplest one, that is the 2-pointer approach, where we are going to use a slow pointer and a fast pointer, which is used to find out your loop in a linked list. So what we do is we create 2 pointers in the linked list. One is a slow pointer which is moving a 1 step ahead, and the second will be moving 2 step ahead at a time. So that means that when the both pointers will meet, if the both pointers will meet, then there is a cycle exists, and if there is they don't meet, I mean the end of the list is encountered, then that means there is no cycle. So I'll just show you on the paper how it is pictorially represented. So I have written the solution, I'll just show you once. So this is where this is the approach one that I'm telling you right now. So you can see here, so the first thing will be how to find this one, the loop in a list. Okay, so as I explained you, we'll take 2 pointers, both will start at this position as I have mentioned here already. Okay, yeah, So there's a slow pointer and there's a fast pointer. So the both has been initialized to the head of the linked list. Now we need to move slow pointer to the slow of next and fast pointer to 2 steps ahead. So the slow will move here and the fast will go here. Now slow will move to this point and the fast will be here. Now the slow will move here. Now the fast needs to move 2 pointers. So the one is this one and the second is this one. So at this point the both pointers will meet here. So in this case, right now we can say that the cycle exists. So basically if the slow pointer meets at fast pointer, that means the cycle exists. If suppose after 4 there is no link to this one, the second node, and there is a link to the null node at the next, so we would have directly returned as null since there is no cycle in this case. So that's how we would have done. But right now since there is a cycle, so now we need to find out the first node of the cycle. So I have created a logic here, so I'll just explain you. I mean, you can see in this picture what is happening is I have created a list which is starting from the head to a point where there is a cycle in the linked list has started. So suppose now I need to find out a point in this cycle. I mean, we need to find out this point where the cycle has started. So from the above approach, from this approach, what we find out is, suppose in this, at this point both pointers have met. So this is the point we are considering this as a point here, this point which I have pointed here. So now I have taken some of the, I mean, I have created an expression how the things are moving here. So I'll just explain you. So imagine from the head of the list to the starting point from where the cycle has started, the node, then we need to consider that node from where the cycle has started. So this distance from the head to the beginning of the cycle node I have considered as a m. I have written here also distance of the first node of the loop from the head. Now the length of the cycle, this complete cycle, I have considered it as a n. You can see here length of the cycle is n. Now there is a variable k that I have considered here and I have marked here. So see the definition of this one, distance of first node of cycle from the node where the slow pointer and fast pointer meet. So what this means is, in the above example, if you see the slow and fast pointer meets as 0. So what is the distance of this point from the point where the cycle has started? That variable I have considered as a k. Okay, so now let's just see how the mathematical calculation for this one works, for the logic to work. So what I have done is, uh, since I have explained you all the variables, so this is a approach for your fast pointers. I mean, left hand side I have considered as a fast pointer and right hand side I have considered a slow pointer. Okay, so if you see on the left hand side, so what I did is we have taken m steps because we have to take the m steps until to find a loop. So m steps, then we'll move ahead. Then we might need to take multiple rounds in order to make the pointers meet, the slow and the fast pointer. So the number of cycles taken by this fast pointer in order to meet to the slow pointer. So there's a n is the length of the cycle and the x is the total number of cycles taken by fast pointers before meeting the slow pointer. And on the right hand side, slow pointer. So since fast pointer is moved with the twice the speed of slow pointer, so we need to, in order to equalize this one, we need to multiply this equation by 2. So the same equation holds here also, but instead of x it will be y, and the y means that total number of cycles taken by small pointer. Okay, so now I just solved this problem, and after solving I have find out this final equation, this equation. So what this equation means is, there's a m plus k, that means m plus k where this point met. So this is a your multiple of n. So this is this statement I have written here, that m plus k is a multiple of n. That means that n is a length of a cycle and m plus k, what is m plus k? So m is your distance of the first node of the loop from the head, and k is your distance of the first node of the cycle where the slow pointer meets. So what does that mean is, where whenever you are at this point, okay, you are at this point, this slow pointer. Now what you need to do is, if you make your fast pointer moves to the speed of a slow pointer, then they, they both will meet at a point where the list has started. How we can say that? We can say that based on this condition, because it is a multiple of m plus k. So we have already moved m plus k steps. Now for the slow pointer, what we'll do is we'll initialize the slow pointer from the head. Okay, slow pointer will be initialized from the head of the linked list, and the fast pointer will remain where both the nodes have met. So in this example, both nodes are going to meet at this place only. Okay, so what we do is we make both pointers now move one step ahead. So both pointers will move with the same pace. So they are going to, so if you see, based on this logic, and based on this logic, now you try to apply the same logic on this particular example. I'll just clear out whatever I have written here, I mean pointed out here. So in the last example that I have shown you already, so the slow and fast pointers are met at this point only. Okay, so now what will happen is we'll take the start pointer, point to the head node. So this your start is gonna point right now at this point only. Okay, now the fast will still remain at the same place only. So what we'll do is we'll move the both pointers to one step ahead. So both are moving at the same place only. So fast will reach here, slow will reach here. Now again slow will take one step ahead, the fast will again take one step ahead, since they both gonna meet at this point now. Okay, you can see here both are meeting at the beginning of the cycle only. So why they both meet at this point only? So as I already explained in the logic, so you can see that when slow pointer reaches the beginning of the loop, it has already taken the m steps. Okay, and by the time this fast pointer will also would have taken the m steps, but it has started from the kth position. Okay, since m plus k is a multiple of n, and since both fast and slow pointer both moving with the same pace, so eventually they both gonna meet at the beginning of the list only. Why they can't meet before or after the beginning? Because the slow pointer has entered into the again started from the head um, once after the completion of m steps. So that means that it is ultimately gonna meet at this point only. So that's how this solution works. So this is the solution to the first approach. Now I'm gonna explain you the second approach, which is probably very easy, but yeah, I will just see the time complexity for this one. So time complexity for this case will be your big O of n, since we need to traverse the list once to find the loop, and then we need to again traverse the list to find the beginning of the loop. So it will be ultimately O of n plus O of n, which will eventually be your O of n. The space complexity, if you will see, that will be your constant space, because you are just using the 2 pointers, nothing else. So slow and fast pointer using, you're not using any memory space or anything. So this is the space complexity, and this is the time complexity in this case. Now we will see the other approach. So the second approach will be the easiest approach. I mean that this is also easy, the first one, but yeah, the second one is more easier, as we are using the collection set. So what we'll do is we'll use a set concept here. We're gonna use a hash set here. So as you know, the property of set, that the unique values will be stored in the set. So we're gonna create the set hash set of type list node, and we're gonna store the each node in the set. So if we encountered any node which is already present in the set, we would be returning that as a node where that is the starting point of the node, because the all the values will be contained in the hash set exactly once only. So if they're repeating the values, that means that is the head of the cycle. So but yeah, in this approach, if you see, your time complexity will be same O of n, but your space complexity will also be O of n, because you're using the hash set. So I'll just write it down the solution based on the hash set. So let's just see how it works. So I'll just start. So we have been given the head of the list, so I'll just create a temporary variable with the current name, and I'll just point it to the head of the list. Now I need to create the set of type list node. I'll give it name as a set only. So I'll just create it as a hash set. sorry, oh, hash set which is of type your list node. Now what we need to do is while current not equal to null, that means we haven't reached the end of the list. If we reach the end of the list, we will probably going to return the null directly because there will be no cycle. Now if the current is not equal to null, what we're gonna do is we need to check if your set dot contains this current. That means if this particular node is contained in the set, then we need to return that as a value because that is the beginning node of our cycle. So we'll just return directly the current node. Okay, and if that is not the case, then what we need to do is we need to put that value into the set first. So we'll add that particular node into the hash set, and then we need to increase that node we need to point that node to the next node in the set. So just a spelling mistake here. Yeah, that's it, I guess. Yeah, once again let's check this solution. So yeah, we have created a temporary variable, we have created a set. We are checking set contains current. If it is containing, then we are returning the current. Otherwise we are adding the current node into the set, and we are moving the current pointer of the node. Yeah, list node actually. Yeah, I think yeah, if this it is reaching to the end, we are returning the null. This looks perfect. Let's just see. Yeah, I mean the test case has passed. Let's just try to submit the problem. Yes, so this problem has been accepted here with the memory usage of 43 point less than. Yeah, this looks perfect only.